Hey everyone, welcome to our video today on function operations and compositions. As you can see here, we have a few problem warm-up that at this point you should probably pause this video, try the problems on your own, and you're ready, unpause it to check your answers, or you can also always check the key that's posted online. But here are your answers to the warm-up problems. If you need to take some more time on this, pause the video now to look these over. Otherwise, we're going to get started with our lesson for today. First, let's talk about function operations. So we're going to have f, which is 4 minus x squared, and g, which is 2x minus 3. We're going to find each of the following and simplify if possible. So the first one is f plus g of x, which is also known as f of x plus g of x. So simply, we're going to take f of x and add it to g of x. And then we're going to combine some like terms if possible and rewrite in descending order, which would then be negative x squared plus 2x, and 4 minus 3 is 1. So negative x squared plus 2x plus 1. Number 2 is f minus g of x, or f of x minus g of x. Okay, so f of x is 4 minus x squared minus g of x, which is 2x minus 3. So that's 4 minus x squared minus 2x plus 3. And again, combining some like terms, we get negative x squared minus 2x plus 7. Number 3 is f times g of x, or f of x times g of x. So it's 4 minus x squared times 2x minus 3. If we distribute, we get 8x minus 12 minus 2x cubed plus 3x squared. And if we simply, there's nothing to combine here, but if we can rewrite in descending order, we get 3x squared minus 2x cubed plus 8x minus 12, which I didn't even do in descending order. Can't move these two around. Now we're in descending order. Okay, number 4. F of x divided by g of x, that would be 4 minus x squared over 2x minus 3. You should probably factor to see if there's anything that cancels, but in this case, nothing will cancel, so either answer would be acceptable. We're going to need these answers for the next slide as well. So number 5, same two functions. Number 5 says f plus g of negative 3. So I'm just going to go ahead and copy down f plus g is right here. All right, this is f plus g. So if we want f plus g of negative 3, we're going to put negative 3 everywhere we see an x. So it would be negative 9 minus 6 plus 1, or negative 14. So for g minus f of 4, you got to be careful here because it's not f minus g. Number 2 is f minus g. This is g minus f. So we got to do 2x minus 3 minus 4 minus x squared. 2x minus 3 minus 4 minus x squared, which is 2x minus 3 minus 4 plus x squared, or x squared plus 2x minus 7. Now we can find g minus f of 4, and that would be 16 plus 8 minus 7, or 17. F times g of 5, now this is the same as before, so f times g of 5, we can copy this down. F times g of x. And that would just be negative 2 times 5 cubed plus 3 times 5 squared plus 8 times 5 minus 12. So that's negative 2 times 125, or negative 250, plus 3 times 25, or 75, plus 40 minus 12. So that's negative 262 plus 115. That's negative 147. Finally, g over f of negative 3. So before we did f over g, we got to do g over f. It'd be 2x minus 3 over 4 minus x squared. So then g over f of negative 3, we're going to put negative 3 in there, but you get negative 6 minus 3 over 4 minus 9, which is negative 15 over negative 5. And, I'm sorry, double checking my work here. 2x minus 3 over 4 minus x squared. Negative 6 minus 3, that's where I messed up there. Negative 6 minus 3 is negative 9 over negative 5, which we can reduce to 9 over 5. Knew something looked fishy there. All right. Now, the last operation we do is something called a composition. So a composition of a function. So you see this symbol right here, is a little open circle. It's not multiplication, it's f of g. It's read f of g of x. Okay, or it looks like this, f of g of x. What that means is we're going to take all of g of x and put it in for x in f. But before we do that, let's do a little practice here with substitutions, with evaluations. F of k plus 1. So you're going to put k plus 1 where you see x and simplify. We get 3k minus 1. G of x minus h, so that would be x minus h squared minus 3. X squared minus 2xh plus h squared minus 3. And there's nothing we can do to simplify that, so that's it. That's our answer. All right, compositions, f of g. We're going to take all g Sure, my laser tail isn't working here, but that's okay. We don't need it. We're going to take all of g, which is x squared minus 3, and we're going to put that in for x in f. Okay, so this whole thing goes in there for x. So we have 3 times x squared minus 3 minus 4, which is 3x squared minus 9 minus 4, or 3x squared minus 13. 12 is g of f, so we're going to take all of this and put that in there. So it's going to be 3x minus 4, quantity squared, minus 3. That's 9x squared minus 24x plus 16 minus 3. And we can do a little simplifying here. So 9x squared minus 24x plus 13 will be our simplified answer. Number 13, f of g of 3. So f of g is right above us there. We're just going to put 3 into that. That would equal 3 times 3 squared minus 13, which is 27 minus 13, or 14. And then g of f of negative 4, we're going to put negative 4 in g of f right there. So 9 times negative 4 squared minus 24 times negative 4 plus 13. So that's 9 times 16, which is 144, minus 24 times 4, which is 96, plus 13. Sorry, this is plus 96. So 144 plus 96 plus 13. That should give us 253. Okay, the last thing we'll look at today is when you do these compositions, we're going to look at their domains. So let's take a look at their domains here. So some new functions here. F is root x and g is 4 minus x squared. First, let's find f of g. All right, so f of g. We're going to take g and put it in for f. That's going to be root 4 minus x squared. And that's it. There's nothing you can do to simplify that. Okay? B is g of f. So that's going to be 4 minus root x squared, which we can't simplify that to just 4 minus x. All right, so C says the domain of f of g. So first thing we'll look at is the domain of the inside function, the domain of g of x. It's just a quadratic, so that thing's going to be all real numbers. We're going to go negative infinity to infinity. But the domain of our new function, f of g of x, the domain of root 4 minus x squared is not all real numbers because we can't take the root of a negative number. So we want to set 4 minus x squared equal to 0. That's going to give us x equals negative 2 or positive 2. And draw our number line out. Both those get closed circles because they'll give us 0, which is okay. And pick some test points. We should get negative, positive, negative. So what we want is negative 2 to 2, inclusive. Last one, domain of g of f. At first glance, you might think, oh, 4 minus x, that domain is all real numbers. But it's not, because the domain, the start you want to look at is the domain of f. And the domain of f is not all real numbers. It's 0 to infinity. That's the only numbers that get us back a positive root. So the domain of 4 minus x then can't be negative infinity to infinity because the inside function we're already only putting in 0 to infinity. So there's no more restrictions on 4 minus x, which means our answer is 0 to infinity. Since there's no other restrictions added once we put f into g, we just take the domain of f for our final answer. All right, one more just like that. First, h of j of x. So we're going to put j, which is x squared, into x. Over here, we get 1 over x squared minus 4. And then j of h of x, we're going to put 1 over x minus 4 into the squared here. So 1 over x minus 4 squared. If you want to simplify that out, you can. It'd be 1 over x squared minus 8x plus 16. Now the domains. So first of all, in C, the domain of j. So domain of j is all real numbers. No restrictions there. But if you look at our new function, it can't be 2 or negative 2, right? Because it can't be 0. We can't have a 0 in the denominator. So our domain then is going to be everything but 2 and negative 2. Everything before negative 2, everything between, and everything after 2. Exclusive of the endpoints. And lastly, the domain of j of h. First of all, the domain of h. So domain of h. It could be anything except for 4, right? So the domain of h is everything before 4 and everything after 4 exclusive. The domain of our new function here, if you look at our new function, it still just can't be 4. There's no new restrictions on it. So since there's no new restrictions, the domain is just going to be what it was originally, everything but 4. Okay, that'll do it for our look into compositions and the operations of multiple functions. Thanks for tuning in today.